I'm Randy Powell, CEO of International Silica Technologies. We're a startup company with patented breakthrough technology to convert rice residues, primarily rice hulls and rice straw, to high purity amorphous silica and renewable energy. Many people don't know it, but silicas, high purity silicas, are used in a variety of products of everyday living. And we'll talk a little bit more about products in the future. This is a sample of our Stratasil branded amorphous silica. And we'll be producing the only bio-based or biogenic silica in the global marketplace. Currently, all the synthetic silicas that are sold into these applications are made from sand with energy-intensive processes that use acids and bases to produce the product. I'm here today with our co-founder and Chief Technology Officer, Larry Shipley. Larry, could you tell us a little bit about the innovation that led to development of our patented technology?
Sure, Andy. Several years ago, we were packaging rice hull ash, which is this material, and it's about 30–40% carbon, and the larger amount of the rest of it is silica. The rice mill that was generating this material that we were packaging was burning the hulls because rice hulls are of significant volume when you're in the rice milling business. You get about 20% of all the incoming rice ends up as hulls, and 20% of the hulls is actually silica. And they burn the hulls to reduce the volume, but they end up with this black, essentially worthless ash. The microporous silica contained in the hulls, if you could remove all of the carbonaceous material, other impurities from it, would be worth several $1,000s a ton. Now, this is when rice hulls are virtually worthless, so it seemed like a good trade. We looked at that process and we looked at the history of what other people had tried to do to recover the silica. The first patent I recall was from 1907, and it was a new kind of furnace, a specialized temperature profile for burning the hulls, but it ultimately didn't work. And all of the other efforts that I found in the literature were variations on trying to carefully burn away all the carbonaceous material, and none of them worked. So it occurred to us that we need to take a different approach. And thinking about why the carbon wasn't burning away, it seemed likely that it was because the lignin and cellulose in the hull were very long chain polymers, and the longer the polymer chain, the more difficult it is to have a clean burn. So we thought about how we would shorten that, and one approach was to treat in a slurry with hydrogen peroxide. Hydrogen peroxide would go in and essentially act like chemical scissors to shorten the polymer chains, and we took that approach, re-dried the hulls, and when we burned them on the bench, we got a nice white powder.
Excellent. You know, a key aspect of our technology is that it's commercially ready and it's been proven at scale through extensive piloting. Tell us a little bit more about the pilot plant experience and what we learned from that.
Going into our piloting program, what our ultimate goal was to do was to eliminate the typical problem that chemical process industries have in development of going from pilot to commercial scale. We wanted to eliminate that by working our way up to commercial scale operation, actually in the pilot plant. And we did this by starting out with a partner at a chemical plant in Nebraska, and we were able to set up our pilot plant inside that chemical plant so that we could use their infrastructure, utilities, maintenance people, all that. And we started out with about a 400-liter reactor for our wet process, and did that batch-wise for a number of months. Then when we were successful with that, we moved to successively larger backmix reactors, ending up with a 5,000-gallon commercial-sized backmix reactor for the wet side, and a continuous belt filter for removing the water slurry from the hulls, commercial-sized hull dryer. And then we built our own 8-foot diameter suspension furnace to burn away all of the carbonaceous materials from the hulls, so that you get a nice pure white powder instead of the black carbon-laden ash that you get if you don't use our patented process.
Thanks for that description, Larry. Obviously, our process now is ready for our first commercial plant, and we're here in Greenville, Mississippi, where we plan to build that facility. Before we go to the plant site and look at the rice mill where we'll co-site our plant, I'd like to say a few more words about the many products that high-purity amorphous silica finds its way into. High-purity amorphous silica is a $4 billion global industry, and silica is used in a wide variety of products of daily living, from toothpaste to tires, and from powdered foods to paint. In toothpaste, silica is added as the active ingredient, the abrasive agent that cleans our teeth. In tires, it's used to extend tread life. In powdered foods, silica is added as an anti-caking agent and improves the flow of powdered materials. Here we have some examples: powdered milk, a powdered spice, and also a powdered drink mix, all which contain amorphous silica. Finally, in paints, another major application for amorphous silica, it improves the flow characteristics so that you get a nice even finish when you apply the paint to a wall. So amorphous silica is found in all of these products and actually many more. Our Stratasil high purity amorphous silica will be the only bio-based, biogenic silica in the global marketplace. Now we're going to move to the producer's rice mill site here in Greenville, Mississippi, to have a look at the site for our first commercial facility. I'm here at the producer's rice mill site in Greenville, Mississippi. Producers is a 2,500 member cooperative with headquarters in Stuttgart, Arkansas, and a major mill in Stuttgart, as well as this mill in Greenville, and many rice collection facilities around the Mid-South Delta. We've agreed a highly synergistic partnership with producers to co-site our first commercial facility. This 25-acre plant site has a southwest corner where we would co-site and install our facility, and producers would supply us rice hulls from their captive supply. We in return would supply renewable process energy to them to fuel some of their operations here. We're very pleased to have producers as a partner for our first commercial facility. We're very excited about our first commercial facility to convert low-value rice hulls into high-value amorphous silica here in Greenville, Mississippi, and we appreciate your interest in our company.